In this episode of the CySec101 training series, we're going to go through the Metasploit exploitation room. So we're gradually just going to get more and more advanced with Metasploit through the next few videos. And this is a part of the exploitation basics module that is a part of the cybersecurity 101 pathway of TryHackMe. And in the last two videos, we did the moniker link introduction as well as the Metasploit introduction by itself, just so we can understand what the interaction with Metasploit is going to look like. And today we're going to do some actual exploitations, and then there are several machines that we are going to exploit today. So you see these green buttons right here. These represent various target machines that we're going to be exploiting today. So it's going to be a fun one. It's going to be a really good room, and we're going to get a chance to try out some really nifty little things with Metasploit. As always, there's going to be the intro, there's scanning techniques, Metasploit Database, the vulnerability scanning, exploitation, MSFVenom, which helps you to create payloads, which is a very, very powerful little feature of Metasploit. And of course, there's the summary and the finishing thoughts and your last notes before you are dismissed for the day. So I'm excited about this video. As always, I love anything that has to do with exploitation and pen testing, so this is going to be a fun one, and I think you're going to get a lot out of it too. If you'd like to support this channel, consider joining Hackaholics Anonymous, the premier community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master. And each tier gets their own Discord server and early access to content, but the agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And you can join by simply clicking the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhackshackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let's jump into the Metasploit exploitation room. In this room, we're going to learn how to use Metasploit for vulnerability scanning and exploitation. We also cover how the database feature makes it easier to manage pen testing engagements with a broader scope. We're also going to look at generating payloads with MSFVenom and how to start a Meterpreter session on most target platforms. And we actually kind of did that in the last video. It wasn't really a requirement, but I just went down the rabbit hole and we were able to do it. So you should see, this would technically, if you haven't seen any of the other Metasploit videos, this would be your second time seeing how it's like to get a Meterpreter session. We're going to learn how to scan target systems using Metasploit, how to use the Metasploit database feature, how to use Metasploit to conduct a vulnerability scan, how to use Metasploit to exploit vulnerable services on a target system, and how MSFVenom can be used to create payloads and obtain a Meterpreter session on the target system. For all the questions that require a word list, we have this specific word list that's been installed on our attack box. But if you have membership to TryHackMe, you can also just download it. And then I feel like you can pretty much just kind of like you find GitHub or some kind of link online where you'd be able to download the text file that has the Metasploit word list as well. So it shouldn't be hard to be able to track that down if you're just going to use your own Kali Linux box or something like that to run these exercises. Please download the word list by clicking the download task files if you're going to use your own machine, or just find it online. And that's pretty much it. And we're going to just do MSF console to make sure everything is up and running. And then we're going to start the very first exercise with scanning. All right, so this is what it looks like when you actually run MSF console and you start it up. This actually says Metasploit. The last one, it was a picture of a duck that we had over here. We have version 6.4.38 with 2,460 exploits, 1,468 payloads, and 9 evasion techniques that are in here. And that's basically it. That's all it looks like when you actually start this whole thing. I can always type clear to clear the screen, and then my command line is going to just show MSF6 because it is already in there and we are ready to run and gun. So the very first exercise that we have here is under scanning, and we can do a variety of scanning techniques. You can use Nmap with Metasploit if you wanted to. There is port scanning. There's a specific port scanner or a variety of different port scanners that are available over here, and these are all under the auxiliary module or modules of Metasploit. And then so you basically search for it, right? So search for port scan, and then it shows you what the various port scan elements are. And then from here, you could just choose one, right? So This one they did scanner port scan TCP, which is, I want to say it's this one. So you could just do use number 5, or just use that whole thing and type that whole path out, and then it'll change your command line into this, and then show the options. And then concurrencies, the number of targets that can be scanned simultaneously. The ports would be the port range to be scanned. 1 to 1000 will not be the same as using Nmap with the default configuration, because Nmap scans the most 1000 used ports, while this is actually scanning port 1 to port 1000. And then our host would be your remote host, the target host that you want to be scanning. And then the number of threads that'll be used simultaneously is represented by the word threads. And if you ran Nmap directly, this is what it would look like. As you probably already know what Nmap looks like, it shows us what these open ports are and the various services that are attached to them. And then we have the UDP service identification scanner as well, where you would just choose that and then run it. And there are so many options that are available with Metasploit. So there's, of course, the SMB scan, the server message block scan, which you would just choose that and then run that. And there's just a variety of other scans that are available. So when performing service scans, it would be important not to omit more exotic services like NetBIOS. NetBIOS, which is the Network Basic Input-Output System, similar to SMB, allows computers to communicate over the network to share files or send files to printers. NetBIOS name of the target system can give you an idea about its role and even importance. So, for example, DevOps, sales, or something like that. That would be typically the name of it. So you may also run across some shared files and folders that could be accessed either without a password or protected with a simple password like admin or administrator or root or tor, something like that, like the basic default passwords. And then Metasploit has many modules that can help you have a better understanding of the target system and possibly help you find vulnerabilities. It's always worth performing a quick search to see if there are any modules that could be helpful based on your target system. So that's basically it. Like, we just got an example of a few different scans, and now we are trying to see what the answers to these questions are over here. So first we want to see how many ports are open on the target system. And of course, there's a variety of different ways that we could actually do this. So I will do, for example, search port scan as they did on the very first exercise, and then we will use the TCP port scan. So what do I have? It's number 5. So I'll do use 5, and then it'll change my command line into it. So you see it changed it to scanner port scan TCP. And then now I need to see what options I have to customize for this in order for this to actually run. So we will do show options, and it's going to show us our required options, and most of these things have already been filled. The only thing that's not filled is the R host, which is the target that I need to scan. So for that, I'm just going to do set R hosts, and then I'm going to type in 10.10.165.158 because that's the R host, the target host that I've been given for this specific task in this exercise. And that's it. We're pretty much done. So what we can do now is we could just do run, press enter, and it'll start running. And then it starts giving us all of our open ports live as it's doing its scanning. So right now there's 4 open ports, and then there you go, that's 5. I'm gonna wait until this finishes. Oh, there we go. So it finished. So we have 5 open ports, and that would be probably I think that is actually the answer is 5. So let's see. Yeah, it is 5 right here. So 5 would be the number of open ports, and then what we can do is we can even do an Nmap scan real quick. So if I do SS and then just do the same thing where I just run the IP address against it, I don't have to do any configuration, right? It's because it's literally just using Nmap, so I'm not using any specific type of auxiliary. And notice how I was even able to run Nmap while I was technically in the context of this auxiliary, and it still worked for me, and it still gave me the options over here. So we're all good here. But the very different or the extra information that I was able to get with Nmap that was not available with our TCP scanner is that it's actually telling me, you know, this is the FTP port, this is secure shell, this is the NetBIOS port that we have, this is Microsoft DS, and then this is our HTTP or web server, something like that. So we actually get some good information about the services that we have. And the next question that we have is here is use the relevant scanner. What NetBIOS name can you see? So we need to use our NetBIOS scanner and to be able to use our relevant little name. So let me see which one the NetBIOS scanner. Is there one over here? I don't think there is, but let's see if they give us one. If not, I just have to search for it. Yep, so there is no NetBIOS scanner that they have actually like given us or displayed in the examples here. So we are going to go back from what we have here. I'm going to search for NetBIOS, and then let's see what I can get over here. So I have an auxiliary scanner, spoof, server, admin. There are two scanners. One of them is auxiliary scanner, NTLM info enumeration. This one is auxiliary scanner, NetBIOS. And so I'm just going to rely on that one. So we'll do use number 2, which is our NetBIOS NB name, which is probably what we actually want anyways. So then we're going to do show options to see what options we need to set, which is everything's been set for us. The R port, I think, was it 137 on the scan that I totally forgot. Okay, let's do nmap one more time to see. I think it was 137. I'm not sure. I can't remember. But let's see, 10.165.158, and it is 139 is the port for NetBIOS over here. It's not 137. So what I need to do is I need to change it. First, I'm just going to do set our hosts while I have the IP address on the screen here. And there we go. And then set our port is going to be 139. And if we do show options now, everything should be set, and indeed it is. So let's run it and let's see if we can get that name. Okay, so it's completed, but it's not giving me any of the information that I need, and I wonder why that is. So I will do I'm gonna do an SV, and I'm going to do an O, and actually I can probably just do A. Like, so if you do nmap dash capital A, it'll give you everything. And I'm going to do it on the port 139, which is our NetBIOS port. And then I'm going to do the IP address here. And let's see what we can get if we'll actually get the name that we want. Because, I mean, it completed here. It did say that it's complete. It didn't give me any kind of error messages. So it just didn't output any information for me onto the screen, which is kind of against the purpose of the whole thing. Okay, so this is what we get. So this is all of the information that can be gathered from our beautiful nmap tool that we have over here. And if we go all the way at the top, we can get to see everything that it's pulled for us. And from here, we can try to see if we can find the name of our given NetBIOS machine. And unfortunately, that did not yield any results as well. But the hint that we have over here on this question is telling us to actually use this specific auxiliary that we're in, the NetBIOS NB name. And so I'm going to run it one more time as is. And then if not, I'm going to change it back to its default port that it had, the 137 port. And then we'll see if that ends up yielding any kind of results for us. If it hopefully one or the other does, and because that's literally what the hint was that they gave us. And at some point when I did this room, it worked because I have the answer. So that's the piece where I'm like, okay, well, it has to work because it's worked before. So we're now going to go back to show options because that time did not yield any results for us either. So we're going to do set our port, and then we're going to put it back to 137, which was the default. And then we're going to run it one more time. And let's see if it works based on the default port that it was configured for. Yeah, okay, very good. It worked based on the default port. So even though when I ran nmap, it said that the NetBIOS was on 139, the specific port right here, and I guess it's very important because it is looking for a UDP target port, even though we didn't have port 137 open when we ran nmap. We only had 139. Let me see if I can go back to be able to find it right here. Yeah. So this is what we had over here. We didn't have 137 open. We only had 139, which is a TCP port that was open. And it's looking at 137 as the default port that's been configured. And it actually shows us right here. So OS Unix name, Acme IT support. And basically that's it. And that's the answer, Acme IT support. So what is running on port 8000? We already got that information as well. And that was on our Nmap output that we had. It was an HTTP, but we do want the extra information about it because I don't think that was actually giving it to us previously. It just says HTTP-alt. So we want to see what is running on port 8000. So what we're going to do is we're going to do a very similar scan that we did for port 139, except this time we're just going to do it for port 8000. So very, very simple. Let me clear this screen right here, and I'm going to just leave my auxiliary that I'm in. And then from there, we are going to do nmap, and it's going to be -A, and then it's going to be -P for port, and then we're going to do port 8000, and then it's going to be on the IP address 10.10.165.158. And it's going to take a couple of seconds, and then hopefully it'll give us what is actually running on port 8000. And the hint says, oh, use HTTP version module. So I'm not even supposed to be using Nmap. I just default to Nmap. So I guess if I don't get it from Nmap, I'm just going to do HTTP version. It actually did give it to me right here, though. So HTTP server WebFS 1.021. That is actually the answer that we have over here. But let's do the HTTP version module as well. So let's do search HTTP HTTP version, and let's find that module real quick. And there's only one, so we're just gonna do use 0. And that's what that looks like. So when you search for something and there's only one option, you just do use 0, and it's not going to turn it into that. And then let's do show options. And these are all the options that we have. So the only requirements, of course, are our hosts and the port and the threads. And most of these things have been configured for us. In this particular case, what we're looking for is the port 8000 because it's not port 80. So first and foremost, let me just change the IP address to this thing. Let's see, it's going to be set our hosts and 10.10.165.158. Okay, there's our hosts, and then we need to now set. I'm gonna run it just by itself, just in case it works on the default for whatever reason. But I feel like I need to change the port to port 8000 because that was the port that was open for our web server. Yeah, so nothing happened here. So what we're going to do is do set our port and set that to 8000. And that should actually work now. And it did. Look at that. So WebFS 1.21. And that is indeed the answer that we're looking for. So perfect. And our final question here, it says, what is the Penny user's SMB password? Use the word list that's mentioned in the previous task. And it says, use the SMB login module. So we actually get to use a word list to find somebody's password. How crazy is this? So we need the what is it? SMB login. So I'm going to search for SMB login. And let's see what there's literally only one option that shows up for that. So we're going to use 0, and then we're going to show options. And there's a lot of stuff over here. Let's see, what do we need to set? Obviously, we need to set our hosts. There's nothing else that's required. No, there is. Okay, so we have abort on lockout, anonymous login, brute force speed. All of those things have been pre-configured for us. And then we need what else do I need? Password file. I believe this is the one that we need right here that we need to set that has not been configured. and then the R host, which is what we need to set, and then the SMB user is what we need to set as well, and user pass file containing users and passwords separated by space, and then user file and verbose. Okay, so I think I only need to set the SMB user, and then I need to set the R hosts, obviously, and then I need to set the pass file, the file that contains passwords. Okay, so first let's do set R hosts, which is again gonna be this guy, and the user was Penny, so we're going to do set SMB user to Penny. Okay, very good. And then we need to set the password file to the path of this thing right here. So let's do that real quick. Okay, boom, we got it. So we got the R host has been set. SMB user is Penny. Pass file is the path to the file for Metasploit word list. So let us now run it, and let's see if we can get the password for Penny. That worked extremely well. That was like really freaking quick. That was amazing. And that's the password, Leo1234 success. That is indeed the password for Penny. And if we go to scanning right here, we will see that that is the password for Penny. So very, very exciting stuff. I love the fact that that worked. We're going to exit out of that specific module, and we're going to clear the screen. And now I'm going to move on to the next couple of tasks, and then we have to completely switch out our virtual machine to be able to attack the other ones that we have over here. So, but for this particular task, we are officially done, and we can move on to the next one. In actual pen testing exercises that you would run in the real world, the engagement will most likely have several targets. This is not what it's like in our particular environment because we're given individual targets to attack. Metasploit has a database function to simplify project management and avoid possible confusion when setting up parameter values. And you first need to start the PostgreSQL database, which Metasploit will use with the following command. So systemctl starts PostgreSQL. And you can actually do that prior to starting up Metasploit. This is at least what they're doing in this particular case. Then you'll need to initialize Metasploit database using the MSFDB init command, and then database is started and adding user MSF, you can now launch MSF console and then check the database status using the db status command. And the database feature will allow you to create workspaces to isolate different projects when first launched. You should be in the default workspace. You can list available workspaces using the workspace command. And then you can add a workspace using the -a for add, obviously, or delete a workspace using -d. And then the screenshot shows how a new workspace named TryHackMe was created in this particular case. And then you type workspace and you can see that there's default, and then there's the TryHackMe, and then we are inside the TryHackMe database. You'll also notice that the new database name is printed in red, starting with the asterisk symbol. This isn't, so maybe when we run the actual exercise, it'll show that. You can use the workspace command to navigate between workspaces simply by typing workspace followed by the desired workspace name. So workspace default would turn you back to the default workspace, basically. You can use the workspace -h command to list available options for workspace command. So this would be the help menu, for lack of a better word. And then it shows you the various options that you have. So list workspaces verbosely, switch workspaces, add a workspace, delete a workspace, delete all workspaces, so on and so forth. You can rename a workspace. Different from regular Metasploit usage, once Metasploit is launched with a database, the help command will show the database backends command menu, which this is what that looks like. And there's a bunch of options inside of that, as you can probably imagine. So If you run nmap using the db nmap, all results will be saved to the database. So that's very useful to know, right? So db underscore nmap for database nmap, and then the rest of it will be exactly as if you're running nmap normally, and then it'll just save everything to that database. And you can now read the information, reach information relevant to hosts and services running on target systems with hosts and services commands respectively. So you could do hosts, and it'll show you the host that you have, services, these services on that host. And these were all discovered from this particular scan. The last scan that you did, it was hosted, or it was saved onto that database, and you're technically inside of that database. So when you look up for whatever the hosts are on your individual database that you're working off of, that's what's going to show you. So if you've done multiple scans on multiple hosts, they will all be shown over here. And then the services for each one of them will be available like this as well. So very, very, very useful. Host-h and services-h command helps you become more familiar with the available options. Once the host information is stored in the database, you can use the hosts-r to add this value to the rhosts parameter. So this is the example workflow. We'll use the vulnerability scanning module that finds potential MS17 vulnerabilities. Use auxiliary scanner MS17, right? We set the rhost using the hosts-r, and then we have typed show options to check if all the values set correctly. In this example, 138.32, the IP address right here, is the IP address that we scanned earlier using the db nmap command. And once all parameters are set, we launch the exploit using the run or exploit command. And so you see this here. This is the actual exploit that we are using, and now we are inside of the context of that exploit, and we set hosts r to actually set it, and then it's going to set the r hosts based on what's inside of the database that you had. And then you say show options, and now it says that the r host has actually been set to your specific host. Now in this particular case, this is saying 10.10.138.32 is the IP address that we scanned, and that's not the address that we have over here. So it is actually 12.229 is the IP address they scanned. So I don't know what they're talking about, but at the very least it's consistent with that, right? This is the IP address that was scanned earlier with nmap, and when they did the command, it actually did set it to that IP address. So that part is consistent. It's just not consistent with the hard instructions that we have over here inside of the documentation, which is fine. If there's more than one host saved in the database, all IP addresses will be used when you do the hosts-r command. In a typical penetration test engagement, we would have the following scenario: find available hosts using nmap, scanning these for further vulnerabilities or ports using port scanning module, and then the services command used with the -s, capital S, will allow you to search for specific services in the environment. So services -s netbios, and then inside of that environment, inside of that IP address that you scanned with db nmap, you'll be able to try to find anything that has to do with netbios, for example. And of course, it's on port 139. So you may want to look for low-hanging fruits like HTTP, FTP, SMB, SSH, RDP. So HTTP could potentially host a web application where you can do SQL injection, remote code execution. FTP could allow anonymous login and provide access to interesting files. SMB could be vulnerable to SMB exploits like the MS17. SSH could be a default or easy guess credentials to give you a remote shell. RDP would be vulnerable to Bluekeep or allow desktop access if weak credentials were used. So these would be the low-hanging fruits that are kind of easy to exploit, assuming that they have weak password policies, right? So if they have really strong passwords, it's most likely these things aren't going to work no matter what. So as you can see, Metasploit has many features to aid in engagements, such as the ability to compartmentalize your engagements into workspaces, analyze your results at a higher level, and quickly import and explore data. There are no questions required to answer. They're just telling us that you can actually do this. You can create a database by just doing the workspace, right? So you can actually create a workspace. You would need to start with, before you even go into Metasploit, you need to first start the PostgreSQL database. So you do systemctl start, and then you start that. And then you do MSF, so Metasploit Framework Database init. So MSFDB init, so that you can actually initialize the Metasploit Framework Database function. And then you launch MSF console, and then you can run the database status just to see what's up. And then it says that it's been connected, and the connection type is PostgreSQL, so you're all good. And then you can start working with the workspaces. And the individual workspace, the very first one is just going to be the default workspace, and then you can add a workspace using -A, followed by the name of the workspace. You can delete it by doing -D, followed by the name of the workspace. Once you add one, it automatically changes you to that workspace. If you wanted to change back and forth from it, you can do workspace and then the name of the workspace that you want to go into, and it'll change you into that one. And then the help menu, as you just saw. And then these are some of the other commands if you just typed help, because that's what's going to happen when you're using the database and you're inside of a database. And then you can start running a tool to house its output into your database. For example, db_nmap is basically running nmap as it would normally, except it's just housing everything. It's storing everything inside of that workspace that you had. And all of this information is now going to be housed and stored over there, and then you can refer to these information. So this would be the host, right? That's the host that you scanned. If we did, 10.10.12.0/24, any IP address that was found inside of that subnet would be hosted, or it would be found inside of your hosts variable. And inside of that value, you would be able to find multiple IP addresses instead of just one that you see here. And then under services, you would see the services for this IP address first, and then the next IP address, and so on and so forth. And then you can use the vulnerability scanner module, for example, like the SMB MS17, which is for the eternal blue. Set the R host value using this R right here. So if you do hosts-R, it'll actually set your R host value for you, and then you essentially are ready to run and gun. So you don't need to once you've done that initial nmap scan, you don't need to memorize the host anymore, right? You basically do host-R, and it'll just set it for you. If you have multiple hosts, it'll most likely set all of them for you. And then you can continue running your exploit or the rest of your exercises, right? So all IP addresses will be used when setting the host-R command. So just keep that in mind. If you have multiple hosts that are stored inside of your workspace, inside of that database, it is going to set all of them when you use the hosts-R command. And then all the available hosts, so on and so forth. So basically, the rest of it is kind of a little bit repetitive, but you get the idea. So now we can move on to vulnerability scanning using Metasploit. Low-hanging fruit is what Metasploit, I would say, specializes in when it does its vulnerability scans for you. Low-hanging fruit refers to the easily identifiable and exploitable vulnerabilities that could potentially allow you to gain a foothold on a system, and in some cases gain high-level privileges like root or admin. Finding vulnerabilities using Metasploit will rely heavily on your ability to scan and fingerprint the target. The better you are at those stages, the more options Metasploit will provide you. For example, if you identify a VNC service running on the target, you may use the search function on Metasploit to list useful modules for the VNC service. Results will contain payload and post modules. At this stage, these results are not very useful as we've not discovered a potential exploit to use just yet. However, in the case of VNC, there are several scanner modules that we can use. So that would be auxiliary scanner VNC in this particular case, for example. And then you will use the info command for any module to have a better understanding of its use and purpose. And so obviously it'll give you the author and the basic options, so on and so forth, and a description of what it actually does. So it's going to test the VNC server on a range of machines and report successful logins. Currently it supports RFC protocol, And then you can see that the VNC login module can help us find login credentials or login details for the VNC service based on what this module provides for us, assuming you discovered that there was a VNC service on the actual target host that you have, right? So who wrote the module that allows us to check SMTP servers for open relay? So what we're going to do is we're going to go and check for SMTP, right? So let's see, SMTP, let's try that. Okay, so from the options, there was 75 options that showed up when I searched for SMTP. There is one that is actually verbatim saying SMTP open relay detection. And I think maybe that could have been something that I would have searched for. So SMTP open relay. Let's see if I can actually do that. So if I do search and then do SMTP open relay, let's see if it'll kind of make that be the singular option that pops up maybe. Yeah, very good. So that is the singular option that actually pops up. So we're going to do use 0, and we're actually going to use this thing. And then we basically just want the info of this thing to see who the creator of it was. And that would be the answer to our question that we were given earlier. And so usually that's at the very, very top. For some reason, this virtual machine is lagging. There we go. Campbell Murray. That's the guy. Campbell Murray. And that's it. That's the answer that we're looking for this particular question. And now we can move on to the next task, which actually will allow us to start exploiting this next machine. So I'm going to terminate this last one, and then we're going to move on to the next machine. And this is going to be fun. This is going to be where the more exploitation tactics are going to start running. All right, so obviously via the name, we can establish that Metasploit is for exploitation. It's the most populated module category inside of Metasploit, as we saw at the very, very beginning. Based on the version 5, there was 2,040 exploits. If we look at the most recent version, I had to restart it because it was kind of going a little bit slow. I think it's like 2,500 or 2,600 exploits since this screenshot that we see right here. So it has the most exploits. It has the most as far as exploits are concerned, and it also has payloads and so on and so forth. These various other options as well, but it literally is designed for exploitation. So we can search exploits using the search command, as we've done multiple times. And we can get more information about them using the info command and launch it using the actual exploit command. While the process itself is simple, remember that a successful outcome depends on a thorough understanding of the services that are running on your target. Most of the exploits will have a preset default payload. However, you can always use the show payloads command to list the other commands that you can use within that specific payload. So for example, inside of Eternal Blue, you can do show payloads, and it has, I guess in this particular screenshot, it only is showing 10 of them. I feel like it has more than 10 exploits that are attached to, or 10 payloads, excuse me, that are attached to the Eternal Blue exploit specifically, right? But it has the reverse or bind TCP shell, the reverse TCP shell, a load library message box interpreter versions, so on and so forth. So once you decided on the payload, you can use the set payload command to make your choice. So you could do set payload to, and it'll send it to the reverse TCP shell, and then show the options. And you can see at the very bottom, it actually has changed the payload to the reverse TCP shell. Note that choosing a working payload could become a trial and error process due to environmental or OS restrictions such as firewall rules, antivirus file writing, or the program performing the payload execution isn't available. So for example, Python shell reverse TCP might not be available. Some payloads will open new parameters that you may need to set. Running the show options command once more can show you those. As you can see in the example, a reverse payload will at least require you to set the lhost option, the local host, because it does need to reverse establish a reverse shell, right? So once you actually do change it to the one that requires a reverse TCP shell, then you need to sell the lhost, which is your local machine's IP address, so that that shell could actually have a place to connect to. And then you run the exploit, and then hopefully it'll work. And now you have the shell that's been completed within that machine. Once a session is open, you can background it using Control Z or abort it using Control C. Backgrounding a session will be useful when working on more than one target simultaneously or the same target with different exploits and or shells. And so this is what Control Z looks like inside of the command line. Do you want to background it? Yes, you do. And then now it takes your command line back to your normal context. And then you can do sessions, and you can see that you have your live session going on in your background. Working with these sessions would be another one of those things that if you wanted to get the help menu, number one, you could just do -H and it'll show you what the help menus are. Typically, you just need to refer to these sessions or reactivate the sessions. That's basically like the big thing that you need to know how to get in and out of. And sessions will allow you to do that by just doing sessions and then the name of the session that you want to change to. For example, session interface or interact, excuse me. So you do session and then interact, and then you give it the session ID, not the name, my bad. So this would be the session ID for this one. So you see that they're inside of this context here. They do sessions, they get the list of these sessions, and then they do session interact 1, and then it takes them back into the Windows System 32 reverse shell that they had previously. So we're going to deploy the target machine and answer the question below. And I have already, I want to say I've deployed it already. It should be running. Yes, it is running. So now we're going to essentially just basically follow some of the instructions that they gave us right here, and then try to get the responses to this. So it says exploit one of the critical vulnerabilities on the target virtual machine. The target is missing the MS-17 patch, so it is eternal blue. And if you don't know, right, so let's say the hint was not available, and we wanted to find out what the vulnerability was for that particular machine. So the way that we would do this is by just going right here. So we would do nmap, right, our favorite little tool, and then we're going to do the SV option, and then I'll do the O option as well. So S, lowercase s, capital V. It's easier if I just zoom in and show you what that looks like. So this is what the command looks like right here. So you do nmap SV because I want to get the versions and I want to get the operating systems on this particular IP address as well for every single port that it's going to find for me. So it's going to run and it's going to give me the information about this thing. And Windows 7 versions of Microsoft on any given IP address or any given service, Windows 7 versions are vulnerable to the MS-17, the eternal blue exploit or vulnerability. So what we're looking for is that specifically. We're looking for the Windows 7 version that would be displayed. And then if you see that, you can pretty much deduce, you can conclude that, yep, that is indeed vulnerable to the MS-17, the eternal blue vulnerability. So if you didn't have that hint, if you wanted to find it, you would be able to do it this way. So I'm just going to wait for this to finish, and then I will show you that. All right, so here it is, right? We have all these open ports here. On this particular port, the 445 port, we see that we have Microsoft Windows 7 running, and Microsoft Windows 7 is the one that has been attached specifically to the vulnerability for eternal blue MS-17, right? And so it's on port 445, which is the default port. And this is all just based on the last video that we did on the introduction of Metasploit, and then we kind of just were given some of that information. And this is one of those things. And it's like, okay, so if you just know, right, if you have that inside of your database, inside of your mental database, and you know that if it's running Microsoft Windows 7, it's probably running the MS-17, or it's vulnerable to the MS-17 vulnerability, the eternal blue vulnerability, then you know that you can run that specific exploit and you will probably be able to log into it without needing credentials or any of those things, right? So that's what's crazy about it. So now that we have this, so now that we know for sure it's on port 445, Windows 7 on this IP address that we have, now we can actually go ahead and search for our eternal blue, and it'll show up. And there's a few of them, obviously, but the very first one that you go at the top right here, you see it's MS-17 010 eternal blue, so on and so forth. So I'm just going to do use 0, and then it's going to change my command line to that. Let me just make sure that it's a little bit zoomed in so you can see this easier. And so now we have this, so we're going to clear the screen, and we have our eternal blue right there. And so we're going to do show options, and it says it right here, right? So these are the local IP address and local port. So this is my actual attack box's IP address right here, which is the default port that it has for the local port. So as it listens, and then for the information that we need right here, we just need the R hosts. That's all we need. And then it's already configured to do the remote port on 445, which is the target port that we just saw that was also open, that had the Windows 7 vulnerability attached to it. And that's pretty much it, right? So from here, all I need to do is just set the R hosts and then run it. And it should give me my shell, my interpreter. So let's actually do that. So this is what we have right here. That's my my target here. So we're going to do R hosts, and then we're going to do this and press enter, and our host has officially been set here. So now what we can do is just do run and watch this thing work. Boom, look at that. Just like that, it connected to our interpreter session. And what's fun with this is that you can technically, even though you know that you are inside of a Windows machine, you can actually run Linux command line commands and it'll still work. So if I do pwd, it'll actually give me my current working directory. If I do ls, oh well, that's not a good idea, because in the system32 there's going to be a bunch of stuff. So yeah, that's going to be a really big output. But again, just doing pwd, it'll say this is where you are. And so let's say I want to go up one, and I go back, and now I do pwd, now I'm inside of Windows. Let's go, I go up another one, and then pwd, now I'm inside of C, and then I do ls here, and it'll say that this is where you are, right? And these are all the different stuff that's here. And we have users, for example. So we'll do cd users, and then we'll go inside of users, and inside of users we have all the users, the default, John, public, desktop, so on and so forth, right? So that's basically it. That's as simple as it gets. So that is the vulnerability that we exploited. So it says, what is exploit the vulnerability, which is what we did, which was the MS17. So that was fine. And it says, what is the content of the flag txt? And it says you can interpreter search command. So let me see if I can go ahead and do a search command for the flag.txt. I see. So we do search, and then we'll do file flag.txt. See if we can find that. All right. So it is inside of John's documents right here. So we have the very powerful search-f flag.txt, and it found the flag for us. So now I want to, where am I again? I'm inside of the user. So I'm going to go into John's, actually John without an H here. And then we are going to go inside of his documents. And are we inside the documents? Yes, we are. So we're going to run the list. There it is. And then I wonder if cat also works. Cat does work. So there you go. So there we go. We concatenated. That's the flag that we have inside of John's documents, and that is indeed the answer. So what is the NTLM hash of the password of the user pirate? Interesting. So use hash dump. Huh. Okay. So let's see. Hash dump. Let me see how that's going to work here. Oh, that was literally so easy. You just type in hash dump, and that's basically it. And so it is pirate, and then the 1001, which is their group, and then this would be the hash, I believe. So let's make sure. No, it's not. Okay, so it's the one that starts with 8CE. So this would be the hash. That's the hash. So there you go. That was freaking easy as hell. Like, how crazy is that? And then, of course, look at this. This is the administrator's hash as well. Now we have the administrator's hash. We have the guest hash, and we have pirate's hash. That's pretty gnarly when you think about how easy that was. I didn't need anything. I didn't need any kind of credentials to be able to get into this Windows machine. Once I got inside the Windows machine, I was able to navigate freely. And then, of course, I ran hash dump and it just dumped the hash. It's gnarly. Very, very cool. Okay, cool. That's it. So that's all the questions that we had here and all the answers for that. So let's go to the MSFVenom, which requires that I terminate this machine and then start the next target machine. And I think after this, we'll pretty much be, we'll be done. But there's a lot of questions at the end of this one. So this is going to be exciting to run. And then we can wrap this particular exercise. So let's do that. We'll wait for this to run and then we'll do the other one. All right, cool. This specific target machine that we have is a Linux machine, which is very exciting. I always, for some reason, I just love seeing this black screen with the text on it. It's just, it makes me feel like I'm in the world of hacking. Or not even hacking. It's just, I don't know, there's something about this terminal that's very appealing to me. I don't know why. But okay, so what we're going to do is, since this is going to be our target machine here, we are most likely going to use our attack box to attack that machine. So let's see, MSFVenom. MSFVenom initially was MSF payload and MSF encode, which allowed you to generate payloads, basically. It allowed you to access all the payloads available in Metasploit framework. MSFVenom allows you to create payloads in many different formats and for many different target systems. And you do it essentially from your actual command line. So you don't need to go inside of the MSF framework. You can list the payloads by just doing MSFVenom-L payloads, and it'll show you all of the payloads that it can run. And there's a lot of them. These are not just the full list. And then you can do the format, so the output formats that you want. And you can just do a -- list and then give you the formats, and then it'll be all of the supported output formats that it can actually run. And then encoders do not aim to bypass antivirus installed on a target system. It's more for formatting. So they encode the payload so that it fits the format that you want it to fit. It has nothing to do with bypassing antivirus. It can be effective against some antivirus programs. Using modern obfuscation techniques or learning methods to inject shellcode is a better solution to avoid antivirus. So the example below shows the usage of encoding with the -e parameter. The PHP version of Meterpreter was encoded in base 64 and the output was raw. So this is the command that we have, MSFVenom-P. This is the payload that we're going to create, essentially, reverse TCP. The host is this, the local host is that, and then we have the format being raw and then -e being PHP base 64. And then you press enter, and then it'll just kind of pick and choose from the defaults. If you haven't chosen a platform or anything like that, it'll say it's choosing this platform, and then it's going to choose this arch, and then found one compatible encoder, attempting to encode, succeeded, and then this in particular case, they haven't created an output file either. So the output file in this particular kit, I don't know where it's been placed. This is like a massive, it looks like a very, very massive hash file or whatever. I don't know if this is the actual output file. Is this the out? I don't think it is. I don't think that was the output file, but that's basically, usually you would also declare where you want the output file to be stored, or what, at least what the name of the thing is that you want to create. So similar to exploits, using a reverse shell, you'll need to be able to accept incoming connections generated by the Venom payload when using the exploit module. This part is automatically handled by the exploit module. You will remember that the payload options title appeared using a reverse shell. The term commonly used to receive a connection from a target is catching a shell. Reverse shells or Meterpreter callbacks generated in your MSFVenom payload can easily be caught using a handler. The following scenario may be familiar. We will exploit the file upload vulnerability present in the DVWA, damn vulnerable web application. For the exercises in this task, you will need to replicate a similar scenario on another target system. DVWA was used here for illustration purposes. The exploit steps are generate the PHP shell using MSFVenom, start the Metasploit handler, execute the PHP shell. MSFVenom will require a payload, the local machine IP address, and the local port to which the payload will connect. And then this is the IP address in this particular case. And then we use that on local port 777. And this is the payload. And so this is essentially what it would look like if you actually had the reverse shell PHP file. So if you're going to upload something into a web application, you'll most likely need to actually write the code first, or you need to find it somewhere and then copy paste it, and then you end up uploading this specific reverse shell. The output PHP file will miss the starting PHP tag commented at the, and then the end tag as seen below. So we'll see this right here. The starting and then the end tag has also been commented, I guess. I need to double check and verify. Yeah, it has been commented, because the starting tag that you see right here, this little, what is this, less than symbol, I guess, that would be the starting. That's been commented out. And the end tag has also been commented out. So the reverse shell PHP file should be edited to convert it to a working PHP file. So basically, you remove this piece right here so that it actually looks normal right there. And then the whole thing activates. When you see this right here, it's been commented. Or, well, you're looking at the cat output anyway, so it's not going to be all color corrected. But when you're looking at the full text, you need to be able to remove that initial comment and then just make sure that it actually works. And then you see the initial piece right here, as well as these two /**, this piece right here, all of that has been removed. And now the thing actually works properly. And the very, very last element right here, which did not exist, has also been added. So the question mark greater than symbol has also been added to make sure that it's functioning. And we will use multi-handler to receive the incoming connection. The module can be used with the use exploit multi-handler command. So while you're inside of MSFVenom, you use exploit multi-handler, and then you run that, and you may need to make sure that you set your payload reverse PHP, set the host, set the port. This is the local host, local port. Show the options, make sure everything's actually set. And then once everything is set, you'll run it. And then it says starting the reverse TCP handler. When the shell is triggered, the connection will be received by the multi-handler. If the payload was set as a interpreter in those Windows executable format, for example, the multi-handler would then provide us with a interpreter shell. We have other payloads as well. So based on the operating system, install web server, install interpreter, all that stuff, MSFVenom can be used to create payloads in almost all formats. These are just some examples. In all of these things, the L host will be the IP address of the attack machine. L port will be the port that you want to listen to, or you want your handler to listen on. And the format is very similar. Like, for the most part, everything is similar. So you see this, MSFVenom payload is going to be this. The L host, the local host, and the local port, and then the file will be ELF, as you see here, and then this is, or excuse me, the format is going to be ELF, and then you see this arrow, that thing is going to output it into the reverse shell.elf. So this is the part that I meant where I said you need to actually output it into some kind of a name. The ELF format is comparable to the exe format in Windows. These are executable files for Linux. However, you may still need to make sure that they have executable permissions on the target machine. For example, once you have the shell.elf file on your target machine, you have to do chmod to change the mode and give it execute by doing +x, and then to accord executable permissions. Once done, you can run this by typing the actual shell, yada, yada, yada. This would be the Windows version. Again, very similar at the beginning. And then you have at the very end right here, the only thing that changes is the format. So -f exe, and then you're doing reverse shell exe instead of reverse shell elf. This is the PHP version of it. This is the ASP version. This is the Python version. For the most part, everything exactly is the same. The format just changes, and then the extension on the output file changes. All the examples are reverse shell payloads. This means that you'll need to have exploit multi-handler module listening on your attack box. You'll need to set up the handler accordingly with the payload lhost, These values will be the same once you've created the MSFVenom payload, and that's it. So we're going to launch the machine. The username is Murphy. The password is this. You can connect via SSH or launch this machine in the browser. Once on the terminal, type sudo su to get a root shell, and this will make things easier. Create an interpreter payload in the ELF format, and then transfer to the target machine. You can start a Python web server. If you have not done so, this is going to be the first time we're going to run it, and it's going to be very, very, very fun. And then we should be able to get the interpreter shell, because we're going to be able to transfer the file and then actually execute the file using the target machine, and then we'll be able to get the other user's password hash. That's the whole goal here. So we're going to start from the very top here, and let's see. All right, so I'm just going to use 2 different shells, probably 3 different shells at one point, inside of the attack box, just to make it easier, because I don't want to go back and forth between that Linux machine and the attack box, all that stuff. So the first thing that I'm going to do is I'm just going to SSH into Murphy's account here. So it'll be Murphy at the IP address here, which is 10.10.142.27. Oops, that did not work. So let's try that one more time. I missed the 7 at the end. Very good. Okay, cool. And then the password is, what is it? 1Q2W3E4R. Like that. Okay, cool. And we are now in the machine like this. And so we're just going to do sudo su. And then one more time, we're going to do 1Q2W3E4R. Like that. Okay, now we're root. Okay, so that's the first part. The first part was to get the root login for Murphy, and we've done that. So all good. We're going to clear the machine. ls. Okay, good stuff. So there we go. So there is that. We were able to get our secure shell for that. The next one is create an interpreter payload in the ELF format on the attack box in the machine of choice. So we are going to do the right here, ELF payload right here, and we're going to do it on the attack box. So I'm just going to open up a third one, because we are going to use MSFVenom, and I don't want to leave my MSF console session. So we're going to do MSFVenom -p. I'm literally just going to type this whole thing, and I'm just going to change the L host to my actual attack box's IP address. L port, I will do like 3333, and then I will go ahead and assign that to a name. So here we go. We're going to do this real quick. All right, cool. There it is. And we now have shell 3. There we go. So we have our shell, and interpreter payload has been created here. So now it says transfer it to the target machine using a Python web server. This is the command, basically. This command right here, that's it. It'll turn your attack box into a web server so that you can serve data and then essentially download that payload from the target machine using wget. So we are just going to do that. So we're going to do Python 3 m http.server. It's going to be on port 9000 like that, and there we go. We actually have it. So Python 3 -m and it's now serving on port 9000. And now we're going to go on this guy's machine, and we're going to say wget, and we're going to do http, and then the attack box IP address, which is the 10.10.151.107. And if you're using your own machine, you would do your own IP address, but for me, this is the attack box IP address that I'm using. So that is that, and it's going to be :9000, because it's on 9000, on port 9000, and then the shell3.elf is the name of the file. Press enter. There we go, 100% perfectly done. So now I can run ls, or let's clear the screen. We're going to do ls. We have shell3 right here. So what we need to do is we need to change it into an executable by doing chmod +x. I always do sudo just to, I mean, I'm already root. I don't think I need to do that, but whatever. Shell3.elf. You should be able to do it without sudo, and it should still work, and it should be fine. So there we go. Shell3.elf is now an executable. So there's that. We're good so far. This is good. So we need to go to our MSF console here, and we need to actually use the exploit multi-handler, and there is that. And the configured payload for me right now is this, because I actually changed it to this. but the default payload, if you do this on your own, the default payload is not going to be this. The default payload is going to be some other thing, and you need to change the payload to this. So you literally do set payload Linux and then x86, come on, and then interpreter, and then reverse TCP like that, and then press enter, and it'll set it for you. And where we got that is here. So this is literally where we got it from. Linux x86 interpreter reverse TCP. That's what the payload is, right? So this is the payload. So what we're going to do is we're going to set that payload to the Linux x86, so on and so forth. So now when I do show options, it'll be the L host is my my attack box. The L port I need to change to, let's see, L port 3333. Press enter. Now do show options again. And we have the payload is the right payload. We have the attack box IP address. We have L port here. So let's see, fingers crossed. We're going to run this thing, and multi-handler should start up in a couple of seconds, and it should start listening. And then from there, we go into our target machine, and then we actually run the shell. Okay, very good. Reverse TCP handler is now running. So now the way that we want to run the shell is basically you do dot to imply that you're inside of the current directory that you're in. You do / and then shell3.elf, press enter, and it worked because I see it in the background. So there we go. Interpreter shell is running, works great. So now what do we need? We need a post exploitation module to dump hashes of others on the system. And the hint is to use the hash dump module. So post Linux gather hash dump. So this is what we need to do here. We need to do Control Z to background the session. I'm going to press yes and enter. So it has been backgrounded. So if I do sessions, press enter, I have that in the background. Very good. And the post exploitation was, one more time, post Linux gather hash dump. So what we need to do is we need to get out of this thing, and we're going to do use post Linux gather hash dump, like that. Okay, very good. And if we do show options, it's going to say you need a session. So the session interact with type of a thing. We need to do sessions -I, or let's do sessions. I think it's either ID 6. Okay, got it. So sessions -I and then 6, enter. And now we're interacting with session 6 using the post gather hash dump and now I think it should be fine, right? Oh no, you know what? No, my bad. So let's let's do this one more time. We're going to background our session. Yes, sessions is going to be ID is still 6. Great. So we're going to do show options. That's my bad. So we're going to do this. Show options is that. We're going to set the session to number 6, like that, and then do show options again. And there is that. So the current setting is fine. So now we're going to run the hash dump. There you go. That's what I was supposed to do. There we go. And then we got all of the hashes of these people. So who are we looking for? We're looking for the other user's password hash. So it's Claire's password hash. And it's starting with this $ right here. And it goes all the way to the colon. So it's this whole thing right here. That all is Claire's password hash. And that's what we did. That's what we got. So hopefully that was pretty easy to follow, with the exception of that like last quick little couple of glitches for the post exploitation stuff. You just need to set the actual session to the ID of the session that you backgrounded, and then you just run it, and it works magnificently. It works very well. So that's it. Fairly easy, right? It wasn't that complicated. You get your reverse shell that we did. That one's pretty easy. and then you switch to a sudo user by doing the sudo su. And then we create an interpreter payload in the ELF format by using this command right here inside of our regular terminal. So not inside of MSF console or anything like that, just a regular terminal. And then from there, you have your payload in ELF format. And then you create a Python server, and then you download it from the target machine. So you create the Python server on your attack box, and then from the target machine inside of your secure shell session that you created, you would run the wget, and then you download that shell file that you created, and then you have to change the permission to executable. So remember that part. You got to do chmod +x, and then the name of the file, and then it'll change it into an executable. And then you create your interpreter session by following the multi-handler. And so when you go into the multi-handler, you have to set the payload to the payload of the thing that you created with MSFVenom, because that was the payload that we chose right here. So you just do, once you're inside the multi-handler, you do set payload, and the instructions for that are actually up here as well. Where do we have it? Right here. So when you actually go inside of the multi-handler, the first thing, it says configured payload is the generic shell reverse TCP, and you need to set payload and then give it the name of the payload that you're going to use, which in our case was that Linux payload that we had right here, this one. So this piece right here, you do set payload, and then you would give it that value, and then you set your payload, and your multi-handler is then ready. And oh no, actually you need to also set your IP address to your attack box's IP address, change the listening port to whatever port you designated when you created your payload. So for me, it was 3333. It could be essentially whatever you want. If it gives you any errors when you use your multi-handler and it says it can't make the connection, just create the payload again and just change it to a different listening port. And from there, you should be fine. And that would be the payload that you created, and then you've transferred the payload. It's now inside the machine, and then now you have your interpreter session. You do run, and it actually starts the multi-handler. And then on the target machine, you go and you actually run that file, that ELF file, and then you saw that we got the interpreter session. And then to do the post-exploitation, we just need to background the session, which we did. And then we see the backgrounded session when we run the sessions option here. So you see, what is it? We had sessions. Where was it? Where did I do? My God. We did sessions. There we go. And then it said, this is your session ID. So ID was number 6. So I went to show options, and it said you only have one option that you got to set, which is the session. And then all I needed to do was to set the session to number 6, and then it set my session to number 6. And then I ran show option again just to verify, and then I did run, and then it ran the hash dump post exploitation, and it dumped the hashes for us. And that's all we needed to do to finish the exercise. So hopefully you were able to follow along with that, and you were able to get the same results that I got. All right, so for this exercise, or for today's room, we're officially wrapped, and we have one more that we're going to go through some instructions for Metasploit, and after that we actually have an actual exercise that we're going to run, so it's going to be pretty fun. They're not going to give us too many instructions. We have to basically use everything that we've learned to run those rooms, or that last room. So it should be pretty fun, it should be exciting. And hopefully you actually got a lot of good value from it as well. As you see, Metasploit is very, very powerful, and you can do a lot with it. So I'm pretty excited to continue running these exercises with you to show you some more exploitation with Metasploit. And I hope you had some fun with this one, because this was a really fun room for me. If you did get value out of this video, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out inside of our CySec101 playlist. And we're going very strong with this particular playlist. And then, of course, if you haven't checked out the rest of the stuff on the channel, I highly encourage you to check out the rest of the stuff on the channel. There's a lot of videos, there's a lot of playlists, there's a lot of good stuff that's available for you. And I think you'll get a lot out of it by just checking out everything else that's on the channel. And then drop a comment if you have any questions, if you just want to say hi. Usually I am very attentive and very responsive to the comment section. Last couple of days this week I was pretty sick, so I wasn't as attentive, but I'm pretty solid with the comment responses. So I'll respond to you if you just want to say hi. If you have any questions, I'll answer your question. And if it's a big one, I will create a video or a playlist in response to your question the way that you see right here. So make sure that you like, subscribe, turn on notification bell so that you get notified the next time that a video comes out. And of course, drop a comment, ask a question, say hi, even if you just want to say thanks. Another way to say thanks would be to support the channel by joining the Hackaholics Anonymous community, the premier community for security professionals and hackers. And we have 4 tiers, the supporter, agent, guardian, and master. And each tier gets their own Discord server, early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I really hope I see you in the Discord servers. If not, I hope I see you in the comment section of the channel, and that's it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next video later.